Hello everyone, once again welcome to my channel. In last video we discussed some type of architectures which are used in the central processing units, either in mobile devices or laptops or computers, desktops, workstations. So today we will uh, deep dive in how the computing power of x86 architecture actually evolved over time. It actually started in 1971 when Intel launched their processor 4004, and it and this central processing unit had a 2300 transistors embedded, and the clock speed was around 0.74 megahertz, and the size of placement of these transistor is around 10,000 nanometers. We will keep these parameters in focus while discussing the evolution. So later in 1978, Intel launched the 8086 CPU. It has considerably improved the clock speed, 5 to 10 megahertz, and it actually uh, came up with the 29,000 transistors, which is a very significant improvement over Intel 4004, and the uh, working space reduced to 3000 nanometers for the transistors. In 1989, Intel 80486 came up with a 1.2 million transistors. The clock speed improved further to 50 megahertz, and the technology is further shrink to 1000 nanometer space. In 1993, Intel Pentium came in, which many of us and many of you have already seen and might be used in the past as well. So it considerably increased the transistors embedded, which is around 3.1 million transistors with a clock speed around 100 megahertz, and the space used in the technology is further reduced to 800 nanometers. In 1999, Intel Pentium 2 actually further enhanced the CPU computing power, and it came with 9.5 million transistors as a part of the CPU. The working length further reduced to 250 nanometers, and clock speed enhanced up to 600 megahertz. So this was a great achievement again by Intel. In 2000, AMD came up uh, with a processor who actually uh, surpassed the megahertz into gigahertz, and more than 1 gigahertz clock speed was achieved by these processors developed by the AMD, which is Athlon Thunderbird. At the time of introduction, it was a kind of a very great achievement in the CPUs. It has a 37 million transistors and 180 nanometer is the working space for these transistors. So gradually the workability of the size reduced over time. Number of transistors are increasing, clock speeds are increasing, which is enhancing the overall computing power of these laptops and desktops. In 2006, Intel Core 2 Duo came up, and it was holding 291 million transistors with working space of 65 nanometers. Clock speed achieved around 3 gigahertz. So it was also again a considerable leap into number of transistors, and considerably reducing the working space to below 100 nanometers. In 2011, Intel Core i7 processors were launched, which are around 1000 million transistors, or you can say just below 1 billion transistors, with operational or space used to craft that CPUs around 32 nanometers. The clock speed has increased to 3.4 gigahertz in these processors. Later, in 2017, AMD came up with the Ryzen 7 with the Zen architecture, and the clock speed improved to 4 gigahertz, and it actually accompanied the 4.8 billion transistors with the working space of around 14 nanometers. In 2020, Apple actually came up with a kind of a revolutionary architecture using ARM architecture, which reduced speed to further, and they shrinked to 5 nanometers, and the overall housing 16 billion transistors, and the clock speed achieved was a 3.2 gigahertz. In 2022, Intel Core i9 processors was launched, which has greater number of transistors, like 20 billion transistors. The working space was around 7 nanometers, and the clock speed increased to 5.2 gigahertz. In 2023, actually, you can say a very significant thing happened, and AMD again introduced a very heavyweight in the CPU chips. Increased clock speed to 5.7 gigahertz with 57 billion transistors, and the working space shrink to 5 nanometers. For AMD, it was a kind of a reduction from 14 nanometer to 5 nanometer. In 2024, here it comes, the NVIDIA Blackwell chip comes in, which is below 5 nanometers, 4, and some say in future it will be a 3 nanometer working space with more than 200 billion transistors, and the clock speed is around 2.2 gigahertz. So it is a kind of a most powerful chip available on the planet right now, and that is why you see in 2024 a lot of news about the NVIDIA taking on the other tech giants, and performing exceptionally well in the stock exchange. So that is one of the reasons that they have Blackwell chips housing more than 200 billion transistors, primarily for the GPUs and for the AI work and for the cloud server computational needs. But this chip is considered to be the most powerful right now. What happens in future? And actually it's a very confusing thing, like these conventional transistor based computers might be replaced with the quantum based computers. There is also possibility that the x86 architecture is taken over by ARM architecture, which is where Qualcomm and Samsung is putting a lot of effort. So let's see what happens in the future, but this is a kind of a journey of evolution of how computing power has increased over time in the central processing units used in the desktops, laptops, data servers, following the x86 architecture. Hopefully you will find it interesting, and thanks a lot for staying till the end. Hope to see you soon with another interesting video regarding the computing and laptop. I am also planning to release a video on Toshiba laptop series as well, so hopefully I will come up with Toshiba laptop in next week. So stay tuned. Thanks a lot for watching. Goodbye.